So today we're going to learn our final way how to solve a system of equations. You should be able to solve a system of equations by graphing, substitution, elimination, using multiplicative inverses of matrices, and our fifth way is going to involve matrices as well, but it's going to involve determinants. This is called Cramer's rule. So if you're given the following system, ax plus by equals m, cx plus by equals n, what you can do is you can take your coefficients, okay, and write it as a matrix. We're going to call that D. Okay, we got the x coefficients here, the y coefficients here. Now if you look at the next matrix I have, it's D sub x. What did I do? I took out the x coefficients and replaced them with these values. The y coefficients stay the same. And then I did the same with the y. D sub y, I keep the x's the same. I take out the y coefficients and replace them with these values. Okay? And these are matrices. Okay? Remember, when you have an absolute value symbol around a matrix, that means it wants you to calculate the determinant. That stands for the determinant. So what you do is you find the determinant of D, you find the determinant of D of x, you find the determinant of D of y. To get your solution, you take your value that you found for D of x divided by D. And then you take your value for D of y divided by D. All right, so let's try an example here. Let's look at example A. I want to solve this system. Okay? So our first step, let's write out my matrix I call D. Okay? D is my coefficient matrix. So what are my x coefficients? 3 and 1. My y coefficients are 2 and -1. So let's go ahead and find the determinant. So remember, when you find the determinant, multiply these two together. 3 times -1 is -3. And it's always minus, okay? The determinant, you always use subtraction. Then you multiply these together. 1 times 2 is 2. So D is equal to -5. Just write that up there. D is equal to -5. So now let's find D of x. So to find D of x, what you do is you take your variable matrix that we had in the beginning. Okay. And I'm going to take out the x coefficients. So I'm going to remove the 3 and the 1 and replace them with 0 and -5. And I got that one right here. The y coefficients stay the same. Okay? So d of y would equal 0 times -1 is 0, minus -5 times 2, -10. So d of x is equal to, you get 0 minus -10, that becomes 0 plus 10, which is 10. And then last, we need to find d sub y, d of y. So this time, instead of replacing the x coefficient, I replace the y coefficients. So I'm going to replace the 2 and the -1 with 0 and -5. The x coefficients stay the same. So we'll go 3 times -5 is -15, minus 0 times 1, which is 0, which is -15. So d of y is -15. So to find x, I do d of x over d. To find y, I do d of y over d. So d of x is 10 divided by d, which is -5, would be -2. d of y is -15 divided by -5 is +3. So the solution to this system is the point -2, 3. Okay, questions? All right, so let's look at the next one. Do one more example here. Let's solve this one using Cramer's rule. So, let's find our D. Again, D is your coefficient matrix. So you got 3 and 2, 1 and 3. Let's go ahead and write out what D of x will equal. Well, for D of x, I replace the x coefficients with 5 and 8. The y coefficients stay the same. And then D of y, we keep the x coefficients the same. We'll replace the y coefficients with 5 and 8. So all we gotta do now is calculate each of these determinants. So we have 3 times 3 is 9 minus 2 times 1 is 2. So D is 7. Let's do D of x. 5 times 3, 15 minus 8 times 1 is 8. 15 minus 8, 7. And then D of y will be 3 times 8, 24 minus 2 times 5, 10, which is 14. And we take D of x over D. D of y over D. This gives you your solution. So D of x would be 7 over 7, which is 1. D of y is 14 divided by 7 is 2. So the solution to this system is the point 1, 2.